Hi everyone, in this section we will run a local authorization server using Docker, and we will use Keycloak for this purpose, which is an open source software that provides identity and access management and single sign-on for modern applications and services. First, let's add Keycloak authorization server YAML file to Docker Compose folder. As you see, we use Keycloak image and use version 11.03 that is added to environment file. We set the hostname as keycloak-server and open the port 8081. And in the environment variables part, we pass Keycloak admin user and password for initial login, and also set the port using JBoss HTTP port variable to 8081. By default, Keycloak uses 8080 as port. Keycloak by default uses memory to hold the data, such as for realms, clients, users, roles, and groups. However, in that case, we will lose the data in each restart. So we can export the data in that case as JSON before shutting down the Docker container and use the volume map to load the initial data when running the container. But it will be a bit cumbersome, as you can imagine. So it is better to use a database to persist the data we work on. For this, we will use PostgreSQL. And here we set that information in Docker Compose environment file. DB vendor will be the Postgres, and address will be set as host Docker internal. So what is this host Docker internal? We run the standalone PostgreSQL in our machine, not in Docker. So this host Docker internal is the host of Docker containers. And to reach the host machine from a Docker container, one can use this variable as the host name. Finally, we pass the database user, password, and schema as environment variables. Before running the Keycloak Docker image, we need to create Postgres database schema and user. So if you don't have a Postgres on your system, please go to PostgreSQL.org downloads and install Postgres into your system. Then you can also download pgadmin from pgadmin.org, which can be used for administration of Postgres. After installation is complete, please open pgadmin. It will be opened on browser on localhost using a local port and with a URI browser. You can now log in by entering the Postgres user's password, which you defined during installation. Then please go to Login and Group roles and create a user Keycloak. You can set the password you choose. I will enter Keycloak for password 2. For privileges, I choose superuser for simplicity here. And then go to databases and create a new database called Keycloak. And create a new schema under the database, again with the name Keycloak. Then the Postgres is ready to be used by our Keycloak Docker container. Let's run the Keycloak authorization server YAML file with command docker compose -f Keycloak authorization server YAML up. We can now go to localhost 8081 and open the admin console and log in with user and password we set on the Docker Compose file, which is admin for us. First, we will create a realm called microservices-realm. A realm in Keycloak is the equivalent of a tenant. It allows creating isolated groups of applications and users. By default, there is a single realm in Keycloak called master. This is dedicated to manage Keycloak and shouldn't be used for your own applications. Now we can create a client with OpenID Connect protocol, which we will use when we implement OpenID for the web client. If you want, you can go over the realm options briefly, like logins, client registrations, keys, and security defenses like secure headers such as same origin, and also there is a brute force detection. We will just focus on the required parts in this course to be able to use this authorization server to serve to our research server and web client. Let's go to roles and create 3 roles now. App user role, app admin role, app super user role with underscores. Then create 3 groups, again using underscores between the words. App user group, app admin group, and app super user group, and assign the corresponding roles to the groups, like user to user, admin to admin. We will then create users and credentials. Let's create a user app underscore user with a password you want to use and make the password permanent for simplicity. Also create app underscore admin. And finally create app underscore super underscore user. Then we will add users to groups. And if we check user roles, we see that there are effective roles assigned to users, which comes from the group role mappings, so no need to add the roles explicitly to users in this case. Now please go to the clients and add a client named Elastic Query Web Client. For this client, we will first make access type as confidential, because it shouldn't be public. As you see, the standard flow, which is the authorization code flow, is enabled by default. We'll also enable direct access grants, which enable resource owner password credentials, and as mentioned, this one is not secure, but we will use it only for test purposes. We will add redirect URI as localhost 8184 Elastic Query Web Client login OAuth2 code Keycloak, and also add directly Elastic Query Web Client path as a second redirect URI to be used as a successful path for post logout. We will see it in the implementation section. Then fill the base URL and finally web origins. We set the web origins to allow cores only from this domain, to prevent cross-origin resource sharing from other domains. Then see the credentials in this client definition. We will use this secret with client ID in our services to authenticate client to Keycloak. We will then add some mappers which will be added to the GWT token. We will add groups as group membership to add it to ID and access tokens as well as to user info endpoints, because we want to see groups of user and use it in authorization in our code. Disable full path here and give a name microservices-groups and save. Second, we will add an audience with the name Elastic Query Service and add it to only access token. It is a list of string values. As mentioned, according to OpenID Connect specification, audience claim is mandatory for ID tokens, and it's specified as the audience that is the ID token is intended for. It must contain the OAuth2 client ID of the relying party as an audience value. It may also contain identifiers for other audiences. But here we add it to access token and set it to intended recipient of the token, which is the Elastic Query Service, because we will call Elastic Query Service from the web client, and here we set the target of our web client, which is the Elastic Query Service. And we will check it on resource server by overriding GWT decoder and adding a validation for this audience. We will see it in the implementation section again. Finally, we will add 3 more mappers: client ID with a user session node, set it as client ID for the user session node and the token claim name, and JSON type as string, and again client host with the user session node again with a JSON type string, and finally client IP, again with a user session node and the JSON type string. Those 3 variables also will be mapped to token, and we can reach them when we decode the GWT. At this point, we need to create client scope for each role with the same name. It will be for OpenID Connect protocol, and in the scope tab, we will add the role. By matching a role with a scope, we will restrict the returned scopes in a GWT, and only return scopes that users' roles match. Then return to client scopes in client definition. It should include all client scopes defined in the previous step. Note that a client token by default will include scopes, and Spring Security will map those scopes to the Spring Security authorities by using a scope underscore prefix. To map them to Spring Security user roles with a prefix role underscore and use has role pre-authorized annotation, we need to use custom GWT encoder or mappers. We will see that in the next section when implementing the security. Service account is disabled for this, which is required to be used with client credentials. We can now create a second client with name Elastic Query Web Client 2 for single sign-on. It will be same as the previous one. We will use this in the implementation section to implement a single sign-on solution. For the second web client, we again set the client scopes and define the same mappers, groups, audience with the name Elastic Query Service, and client ID, host, and IP address user session nodes. Now finally create a third client named Elastic Query Service for the resource server, because we want to make some calls from resource server to other resource servers. It will be again same as previous one, but for this one we will enable service accounts. And by enabling service accounts, we can then use client credentials flow which is machine-to-machine call, so we will call from one resource server to another resource server without any user interaction and just using client ID and secret as we defined here. Let's again enter redirect URI, base URL, and web origins for Elastic Query Service. Again, we set the client scopes to client here. And then add again mappers. We will add the same groups mapping for the Elastic Query Service. For the audience, we will add two values, because as we will see in the implementations in the coming sections, from Elastic Query Service, we want to make a call either to Kafka Stream Service or Analytics Service. So we need to add both Kafka Stream Service and Analytics Service, and then we will check on the resource server to be included at least one of these values. Again, we will add client ID, host, and IP with user session node as the mapper type and set the JSON type as string. Now, if we open the well-known OpenID configuration URL by adding it to the end of the URL for our realm definition on Keycloak, we should see public discovery information that Keycloak provides. Let's open it on Postman with a GET request. And here we see all the information like the issuer URL, GWKS URL, token endpoint, user info endpoint, and supported grant types. Now Keycloak is configured, we can continue with resource server security implementation for OAuth and OpenID Connect. Alright, I will see you in the next section.